Hi, I'm an old guy and I do maths. Now, we're told that in general the differential of a tangent is sec squared. And you'll often see a note in textbooks that looks like this. If the function of x is tan kx, then f dash x, the derivative of x, will equal k sec squared kx. And the question obviously arises, how is this and why is this? And the short answer is that it's achieved by differentiating a tangent by first principles, which is not the most pleasant thing in the world to do, but it's doable and it gets us the result. And so I thought today I would just explain why the derivative of a tangent is the secant squared. So let's just get going with this and see how we go. So if our tangent is the tan of x, let's say, then if we were to differentiate this by first principles, we'd wind up with something that looks like this: tan x plus h minus tan x all over h. Now, we don't get very far with this. So what we do is we take advantage of the fact that a tangent is a sine over a cosine, which is what you see here. So this part of our equation is written like this. So tan x plus h is equal to sine x plus h over cos x plus h. And tan of x is equal to sine of x over cos of x. And so we have this expression minus this expression. We still need to divide by h, but just to make life a little simpler, we'll multiply by 1 over h, which is exactly the same thing. Okay, so we'll do some tidying up, and what we get is this. Now, this is simply the result of cross multiplication. We've got two different denominators here and we need to perform a subtraction. It's just the rules relating to fractions. So we multiply these, we multiply this by this and this by this, and what we get is sine x plus h times cos x, that, minus sine of x times cos of x plus h, there, all over cos x plus h times cos x, all times 1 over h, the equivalent of dividing this expression by h. Okay, so far so good. Let's move on. Now this runs for a page and a bit, so here's the bit. Right, what does this all get us? Well, by the time we've tidied up that top row, we're left with sine h. And on the bottom, we're left with h cos x plus h times cos x. Now, you'll notice that the 1 over h has disappeared. We've multiplied through by that, which is why we've got sine h and h cos x plus h, and so forth. And our limit is such that h tends to 0. Well, we can see that. A little more simplifying here. A little more simplifying, and what we wind up with is 1 over cos squared x, because we wind up with this times this and h tending to 0, so our h's basically disappear. Now, what have we got here? We've got 1 over cos squared x. Now, a secant is 1 over a cosine. So, we can rewrite this as sec squared x, and that is our differential of tan of x, and that's how it's arrived at. This is not to be undertaken lightly. It's the proof of it, if you will. Anyway, now you know where it comes from. I hope that was helpful. If it was, you might find some other things of worth on this channel, so please like and subscribe. And I'll see you next time. Thanks. Bye.